All right, guys, lesson 3, let's do it. Okay, so we're talking about parts of a quadratic graph. So just a little bit of review. Quadratic is defined, this is like kind of the most basic form. We'll call that our parent function. Okay, yeah, that's our parent function, right? That's our most basic form. And a quadratic is defined, like you can tell it's a quadratic by this right here. So my biggest exponent is 2, and it's on a variable. Okay, biggest exponent is 2, it's on a variable. So my biggest exponent in here is a 2, and it's on the x, so that's a quadratic. Okay, so graph of quadratic is called a parabola. Okay, so it looks like these right here. So these are parabolas. They look like smiley faces and frowny faces. So all quadratics, do you ever have a maximum or a minimum located at the vertex? So the vertex is kind of defined by being that maximum or minimum. So if we look back at these two graphs, right, look at this one. I have a distinct point here that is the lowest it goes because I have these arrows coming up, so it's going to go up forever and ever, right? Over here, I have a maximum, right? That's the high point before we come down forever and ever, okay? And so those points, this one right here and this one right there, right, they're maximum, we have a minimum, but they're both vertexes, okay? So we also have the axis symmetry, which is a line that of reflection that runs vertically through the vertex and divides the parabola into 2 equal parts. It's always written as x equals something. So if you write x equals any number, it's going to be like a line that goes up and down. And if you look at the one on the left here, right, I have that vertex. That axis of symmetry runs right through it, going up and down. And on each side, I have symmetrical parts, right? So we have the y-intercept, and that's wherever the graph crosses the y-axis. And I have x-intercepts. Sometimes it's 1. Geez, I did not spell that right. All right, there we go. All right, sometimes 1. Two or 0. Okay, so you have some options. We'll get to the zeros later in this class, but for now, it's just going to be 2 and 1. All right, so those x-intercepts, sometimes we call them zeros, and sometimes we call them roots. So you can use x-intercepts, zeros, and roots interchangeably. So if I refer to, say, one of these words, I'm referring to the same thing. So let's look at this first graph. Let me zoom in a little bit. Okay, so I identified the vertex, right? It's that low point, so we have a minimum. And that minimum is my vertex at 3, -4. Okay, where's my axis of symmetry? Well, if I find my vertex has an x value of 3, it's just going to be x equals whatever that x value is, right? So it's going through that line with an x value of 3, okay? I have a y-intercept. I'm always going to have one y-intercept so it can pass that vertical line test. Looks like my y-intercept will be at 0, 5. And my x-intercepts, I have 2 here. I have one at 1. I have another at 5. Okay, so domain. When we're talking about domains of parabolas, it is literally the same answer for every single one. Every quadratic has the same domain. and it goes from negative infinity to infinity. Okay, so these arrows, right, they're going forever. And so they're coming this way, and it's never going to stop. So every single number on the number line that you could possibly think of, and even the ones you can't even think of, right, those are going to be part of those x values. So another way to write negative infinity to infinity is this symbol right here. Right, that symbol stands for all real numbers. So all real numbers, all the numbers on a number line, 0.03256, 5,767,000,000, all the numbers you can think of. That's what that stands for. Okay, range, right? Range is how high up and down I go. Well, I have a low point, and I'm going to use a bracket next to the low point. So basically, whenever you're talking about range, use a bracket next to the number. The low point is -4, so I bracket -4. And it goes up forever, so I'll use infinity. So I use parentheses for positive and negative infinity. Whenever I have an infinity symbol, right, and I have 2 right here, I always put the parentheses, and I'll use brackets for numbers. Okay, so let's look at this one. Okay, let's look at this one. What's my vertex? Well, I go right 2, up 1. I have a vertex of 2, 1. And since it's the high point, it's my maximum. My axis of symmetry is x equals, well, the x value of the vertex is 2. So it's x equals 2. Where's my y-intercept? Well, it crosses right here at 0, -3. And I have 2 x-intercepts, 1 here, 1 there. So I have 1, 0, and I have 3, 0. What's my domain? I don't even have to think about that. It's the same every time. And my range. So since these arrows go down, right, I start as low as you could possibly ever imagine, and then I go up to this point, and that's the highest I go. So my range goes from negative infinity, and I use that parentheses because it's an infinity, and it goes up to a y value of 1. So I'll use the bracket next to the number. Okay, so we're going to be working with vertex form today. Okay, so my vertex can be found easily from my vertex form. Okay, so we have an A. So just like the past 2 lessons, that coefficient out in the front, right, is going to tell me if I'm stretching it or compressing it. Okay, so if I stretch it, it's greater than 1. If I compress it, it's between 0 and 1. And if it's negative, we're going to flip it. Okay, and since it's on the outside, right, we're just flipping up and down. Okay, anything on the outside is up and down movement. Anything on the inside of parentheses is left-right movement. Okay, so that applies to addition and subtraction too. Right, the minus h, right, the h is telling me how left and right I go. And just like the past 2 lessons, right, inside is backwards. So if I have -3, let's say I have -3, I'm moving it to the right 3. If it's +3, I move it to the left 3. And then this plus k, right, that's on the outside. So that's going to tell me how far up and down I move it. Okay, so let's look at the back here. Okay, so you're going to be able to use Desmos, and I would suggest using Desmos to help you out with these. Okay, so my parent function is y equals x squared. So y equals x squared, here. That's our parent function that we talked about. And it looks like this, right? We have a vertex at 0, 0, and it just goes up forever, right? Our default mode is a smiley face. We only get a frowny face when we flip it with a negative. So I have 0, 0 as my vertex, right? I have no addition or subtraction on the inside of any parentheses, so there's no left or right. I don't have addition or subtraction outside any parentheses, so there's not up or down. I don't have an a value here, stretching or compressing, so so there's none of that. And I don't have a negative, so there's no flipping. Well, what's my domain? It's going to be this. And guess what? It's going to be that for literally every quadratic we have, so I don't even have to think about that. My range, okay, so by default, we have a low point. We have a minimum, unless we flip it. And since my y value is 0, our low point is at 0, and it goes to infinity. Okay? All right. Use decimals to help you with this. This is probably the hardest part. I can do it in my head, and some of y'all probably can too, but just use decimals to double check that range. Okay? So let's look at our second one. Okay? All right, so let's do left and right movement before we do the vertex. So that +2 on the inside, right? We said inside is opposite in left-right movement. So I'm going left 2 with that +2. That +3 is on the outside. Outside is up and down, straightforward. So I'm going up 3. So my parent function, like on my basic form, right, up here, we have a vertex at 0, 0. And so these numbers, the addition or subtraction, is telling me where I'm moving that parent function, okay? So if we start at 0, 0, I move it left 2, I move it up 3. Well, I have a vertex of -2, +3. Okay? So start at 0, 0. These will tell you where you're going to be moving it. All right. Dilation. Well, do I have an A value out in front? Nope. Do I have a negative out in front for the reflection? Nope. And my range, okay, so since it's not flipped, we're going to be making a smiley face. Okay. And that y value is 3. So we have a low point of 3, and it goes to infinity. Okay? X squared minus 3. Okay? Am I moving it left to right at all? Well, I don't see addition or subtraction inside the parentheses. So, no. Am I moving it up or down at all? Well, I see that -3 on the outside. So I'm moving it down 3. And since we always start at 0, 0, and I moved it down 3, right? If I start 0, 0 and move it down 3, I have a vertex of 0, -3, right? We take that vertex at 0, 0 and just shift it around. All right, do I have a dilation? No, I do not. I don't have an A value out there. Do I have a reflection? Well, do I see a negative? No, we don't have a reflection. And since it's not reflected, right, we're starting down low, and it's going up in a smiley, and I have the y value of -3, and it's going to go up to infinity. Okay? All right, let's fill out the rest of these. X minus 5 on the inside, that tells me I'm moving right 5. It's backwards. It's on the inside. All right, I don't have a plus or minus on the outside, so I'm not moving it up or down. And so the vertex, if we start at 0, 0, I move it right 5. I'm at 5, 0. Okay? Dilation. Okay? Do I have an A value here? Yes, I do. For this one, I do. I have that 2 out in front. And since 2 is bigger than 1, I will be stretching it by a factor of 2. Okay? Do I have a reflection? Well, I don't see a negative out here, so no. And what's my range? Well, since I'm not flipping it, and I have a y value of 0, we go from 0 to infinity. Right? And you can always use decimals to check that. All right. Next one. All right, let's do up, down, left, right first. Okay. Am I moving it left to right at all? Well, I don't see any addition, subtraction side of parentheses, so I'm not. Am I moving it up, down? Yeah, I move it up 1. That's what this +1 says. All right, so if I start at 0, 0, I move it up 1. I have a vertex at 1, 0. All right, before I do the dilation, let's do the flip. So I see that negative out in the very front. I know I have a reflection, right? We're going to be flipping it from the smiley. We're going to flip it down. And now it's going to be the frowny face, okay? Do I have a dilation? Well, I see the 3 here, right? It says -3. Well, think of it like this, okay? So I already said there was a reflection. Let's say that we like spent our negative to say it was a reflection, and all I'm left with is a 3. So I'll say stretch by 3. Okay, so when we're saying stretch or compress, we should be stretching or compressing by some positive number. Okay, we don't want to say for this one, oh, I'm stretching by -3. That's not what we're saying, right? You spend that negative to say you flip, you're left with the 3. That's what I'm stretching with. Okay, and since I flipped it, right, this y value on the vertex, that's going to be my maximum point, and we're going to go down forever to -infinity. Okay, so going down is -infinity, going up is positive infinity. Make sure you get those two straight. All right, vertex. For this one, well, actually, let's do these first. All right, this +1 on the inside tells me I moved left 1. This -4 on the outside tells me I moved down 4. So if I start at 0, I go left 1 and down 4. I have a vertex at -1, -4. All right, dilation, compression. Well, I have a 1/2 out in front. 1/2 is between 0 and 1. So I have a compression compressed by 1/2. Okay. Zero reflection, I don't see a negative, so no. And since I don't flip it, I have a low value of, well, that vertex has a y value of -4. So I'll start there and I go to infinity. All right. So use Desmos to help you with this, especially with the range. Okay, just reiterating that. All right, we can graph these. So you guys can use Desmos. You can use Desmos to help graph. But I know that my vertex for my basic one is 0, 0. And if you graph it on Desmos, you'll be able to find points. So find 5 points when you're doing this. And I'm just going to do rough graph. Yeah. And it's going to look something like this, right? You'll find your points, but. Okay. Next one is +2 on the inside, -3 on the outside. I have -2, -3. Okay. And since it's not negative, it's going to go up. But you guys need to find your 5 points, and you'll use Desmos. Let me do one more. I'll do number 3 for y'all. I see that -1 on the inside. I know I'm moving right 1. So I have a vertex at 1, 0. And that negative tells me I'm flipping it. So my quadratic is going to come down, right? It's going to open downward. Okay? All right. So use Desmos. Make sure you guys find 5 points when you're graphing these. Okay? So I need like 5 points like that. Okay? And I want you all to do these. And then you guys are going to do the homework as well. Okay?